Okay, today's lesson is 4.3 trigonometric functions on the unit circle. Now, this is the first video on this section. However, I'm starting with the second objective instead of the first one because it makes more sense to me to start with this one, especially just the way it builds. And if I start with this one, it connects to what we've done in 4.1 and 4.2. So, to continue, you talked about special right triangles in geometry. You had a 30, 60, 90 triangle. Both of these are 30, 60, 90. And you had a 45, 45, 90 triangle. So what I'm going to do is if I have a 30, 60, 90 triangle, and I'm going to say that the hypotenuse is 1, then you're going to remember that the short leg is half the hypotenuse, and the long leg is the short leg times the square root of 3, but we don't write 1/2 the square root of 3, we write the square root of 3 over 2. And so from there, then I'm going to go in and say, use my SOHCAHTOA that we talked about in 4.1, and the cosine of the angle is adjacent over hypotenuse. Well, square root of 3 over 2 over 1, so when your hypotenuse is 1, then this is going to be my cosine, and that's going to be my sine. So the cosine square root of 3 over 2, sine is 1/2, tangent is opposite over adjacent, and so that, of course, is 1/2 over the square root of 3 over 2. Now, I'm going to work this out the long way, but y'all, I want to tell you, you should be putting this in your calculator. If you don't have a calculator that does it, I encourage you to use ClassCalc. You can put it in just like that, and it will simplify it for you. But what's happening, because there might be somewhere where you can't use it, okay, to simplify this, we keep change flip. So we keep the top, we change division to multiplication, and then we flip the bottom. Keep change flip. My 2's are going to cancel, leaving me with 1 over the square root of 3, and then I have to rationalize that by multiplying by the square root of 3 over the square root of 3, and that gives me the square root of 3 over 3. So now, when I move on to my same 30, 60, 90, but it's rotated. So the key, y'all, is this angle down here. The bottom one is 30. Well, over here, the bottom one is 60. I'm still going to have a hypotenuse of 1. My short side is now down on the bottom of 1/2, and my long side is going up as a square root of 3 over 2. Okay, because my hypotenuse is 1, I still have the cosine is the adjacent, which is 1/2. The sine is the opposite over 1, which is square root of 3 over 2. And my tangent is going to be the square root of 3 over 1. So that's just going to be the square root of 3. Now moving on to my 45, 45, 90. Again, hypotenuse of 1. This time, my sides are going to be 1 divided by the square root of 2, which simplified gives you square root of 2 over 2. So still hypotenuse of 1 means the cosine is the adjacent side. The sine is the opposite side, and the tangent, y'all, if you put the same thing over, okay, opposite over adjacent, well, that's going to give you 1, okay? Now, why are these things so important? Is because it actually is the foundation. Those special right triangles are the foundations of our unit circle. And the unit circle basically is keeping all this information organized, and you use it a lot when you're solving problems of these types with these angles, okay? So to refresh your memory, okay, the unit circle, it's called unit, y'all, because it's a length of 1. That's why it's called the unit circle. And the equation, it's a circle centered at the origin with a radius of 1, okay? So here's my origin, and that means that this point right here is 1, 0. This point up here is going to be 0, 1. This point over here is going to be -1, 0. And this point down here is going to be 0, -1. I'm at the origin, okay? So if you also remember your coordinates, okay, so I've got the origin here in the middle where everything intersects. Then your top right is quadrant 1. Where'd it go? There it is. Top right is quadrant 1. And then we go counterclockwise. So this is quadrant 2. And down here we have quadrant 3. And to the right we have quadrant 4. Okay. And the other thing you're going to see me and hear me refer to a lot is what are the signs in the quadrant. So X and Y are both positive in the first quadrant. X is negative, Y is positive. They're both negative in the third quadrant, and then we go positive, negative in the fourth. Okay. So we're going to talk about degrees and how the degrees come on a circle. So we always start over here on the right. That's 0 degrees. All the way around my circle is, you already all know this, all the way around is 360 degrees. Halfway around, 180 degrees. And half of 180 is up top at 90 degrees. And if I add 90 and 180 together, I end up down at the bottom at 270. Okay? Now, if you take those triangles that I just did, and y'all, I've color-coded this for a reason so that you can refer back to these triangles. So they're all going to be in the same family, and you're going to see how it kind of fits things together. So if you take that red triangle, which was a 30, 60, 90 triangle, okay, if you think about dropping this down, okay, here is my 30, 60, 90 triangle. This angle right here is 30 degrees. So that's 30. And if I flip this triangle over to my second quadrant, then this angle here is 30 degrees. So what number is 30 degrees before 180? Because if I start here and go all the way there, I'm at 180. But if I stop short, I've stopped short of 30 degrees. So whatever this angle is, I'm going to subtract it from 180. So 180 minus 30 is 150. And I can't seem that, there we go. And then if I go down, flip it down again, this angle is 30. So I'm at 210. And then over here to the right on the fourth quadrant, 30 degrees before 360 is going to be 330. Okay. Now go to the purple triangle. If I put the purple triangle, because this was 30, then the next one up is going to be 45. And then I go across, and it's going to be 180 minus 45. And then I go down, it's going to be 180 plus 45. And then if I go to the right, it's going to be 360 minus 45. Okay? Notice the purple ones all end in 5. The others all end in 0. So we have an angle. Okay, it makes it pretty easy when you're on the unit circle. Okay, this last one, the green one, okay, that was 30. Then we had 45, and now we have 60. So this is my 60-degree angle. 180 minus 60, 180 plus 60, 360 minus 60, or 60 before 360, however you wish to think about it. Okay? Now, I want to go ahead and put the coordinates on here. So if you remember on our 30, 69 triangle, this length was 1, and this is the short side, and that's the long side. But this is my x value. That's the adjacent side. So that is, if I go over and up, it's going to be square root of 3 over 2, comma 1/2. And when I go over to the left in quadrant 2, the only thing that changes about that is that the cosine is negative, or the x-coordinate's negative. Down here, they're both negative. And in the fourth quadrant, only the second one is negative. But y'all, the points are the same. So if you know this one, you know all of them because you already know these signs. Okay, 45 degrees. That's when they were the same. So that was the square root of 2 over square root of 2, comma, square root of 2 over 2. Square root of 2 over 2, comma, square root of 2 over 2. It's a mouthful. Go to the second quadrant, x is negative. Go down, they're both negative. Go to the right, the first one's positive, the second one's negative. And then on my 60 degree, okay, this is 1, this is the long side, and this is the short side. So it's going to be 1/2, comma, square root of 3 over 2. When I go to the left in the second quadrant, x is negative, y is positive. Same numbers every time, y'all. Down, they're both negative, and to the right, first one's positive and second one's negative. Okay? Now, the last thing I want to talk, not really the last thing, but almost the last thing, okay, is something called radians. And you kind of have already had that because we talked about it in 4.2, that you know 0 degrees is 0 radians, no matter what it is. Okay, 0 is 0 in any language that you have. So degrees are radians, but radians is the one unit in measure that we do not have to put a symbol to know what it is. Unfortunately, not consistent in Delta Math, but everywhere else it is. Okay, I'm sure he'll fix it. He's doing a lot of great things. Okay, so all the way around the circle is 2 pi. Half of 2 pi is going to be halfway around the circle, which is going to be pi. And then half of pi is going to be half of halfway. So that's going to be pi over 2. And if you add pi over 2 and pi together, you're going to end up down here with 3 pi over 2. Okay? So to think about your radians, y'all, there's so many different ways you can think about it. But the gist of it is, if you think about how many times 3 goes into 18, it goes 6 times. So this is pi over 6. And that's because if you took this like it was a pi and you cut this piece here, that would be 1/6 of that thing right there. Because that's 1/6, that's 2/6, that's 3/6, 4/6, and then 5/6. So we're going to keep going. Okay, so this is pi over 6. And so the key to remember is all of these in red that are closest to the x-axis are going to be over 6. And this quadrant is going to be all of the numbers, okay, all the numerators are going to be 1 less than the denominator. So pi over 6 is in the first quadrant, but in the second quadrant, it's 5 pi over 6. Third quadrant, it's going to be 1 more, so it's 7 pi over 6. And in the last one, if you go across and you add those two numbers together, remember it's always over 6, but 5 plus 6 is 11, so it's 11 pi over 6. Okay? Now, 45 is 1/2 of 90, and half of a half is a fourth, so it's pi over 4. So pi over 4, go to the second quadrant, top is 1 less than the bottom, so it's 3 pi over 4. Go down, it's 1 more, so it's 5 pi over 4. And go across, and I'm going to go and add these up. So 3 plus 4 is 7. So come back down here, and it's going to be 7 pi over 4. Okay? The last one is, how many times does 6 go into 18? Well, 3 times, so that's pi over 3. Go to the second quadrant, 1 less is on top, so that's 2 pi over 3. Go down, it's 1 more on the top, 4 pi over 3. And go across, I'm going to go up to the second quadrant and see that 2 plus 3 is 5 pi over 3. Okay? So these numbers go in decreasing order, 6, 4, 3, 2. Okay? But more importantly, y'all, if you know this quadrant, you know it all. Okay? Especially if you think about filling it in according to the colors. Okay? So the last thing that I want to remind you about is one of the things that this does is when you have this, you can easily know the sine and cosine of numbers because we just filled it out up here in this triangle. When I had this right here, the cosine was the square root of 3 over 2. Well, if you look at your coordinates, where does that show up? It shows up in the first coordinate. And it's all because we have a radius of 1 here. So whenever I look at any coordinates, all I have to do is look at it and know that the first number is the cosine of the angle, and the second coordinate is the sine of the angle. So if I want the cosine of 300, I just go down here and go, oh, it's 1/2. If I want the sine of 135, square root of 2 over 2. Okay? And then the last thing, I'm a visual. In case you hadn't noted, I like the colors and the visual to help me see things. But the tangent is opposite over adjacent, which ends up being sine over cosine. Okay, so if you can remember, this is the tangent. Okay, so you look at it, and this is what I'm going to tell y'all. And I'm going to go ahead and fill it in for you. I'm going to show you this real quick. Okay, because if you know the first quadrant, you know it all. These bottoms are all 2. So when I need the tangent, all I have to do is look at the top. So I'm going to start up here and go, okay, tangent is this over that. Well, that's the square root of 3 over 1. So the tangent's the square root of 3. Oh, yeah. Come back here. Tangent's square root of 3. Okay? On 45 degrees, square root of 2 over square root of 2 is 1. And granted, we did just do it up top. This one is 1 over the square root of 3, which is not that. So that means I'm going to have to rationalize it, and it's the square root of 3 over 3. But if you know that those are the only 3 possibilities, then when you're looking at it, oh, 1 over the square root of 3 gives me this. So it's an easy way. Remember the tangent, and that means that the reciprocal is going to be the cotangent, so it goes the opposite way. Okay, that was the longest part of the lesson. Let's go do a few examples of what you're going to have to be able to do. and then we'll be done. So the first thing, evaluate trigonometric functions of quadrantal angles. First off, a quadrantal angle is any angle whose terminal side is on an axis. Okay, so that means when you're looking at your unit circle, that's these with the blue dots. Okay, so all you have to do is know where things are. So 270 degrees is down at the bottom. So if you think about it, it's down there. What are those coordinates? Coordinates are 0, -1. Cosine is the first coordinate. So the cosine of 270 is 0. Okay. Cosecant of pi over 2. Pi over 2 is up at the top. The coordinates up at the top are 0, 1. Cosecant is 1 over the sine. So that is the sine value, and 1 over 1 is 1. All right, cotangent of -90. Okay, remember negative means you go in an opposite direction. So -90 is going to be down on the bottom. Coordinates are 0, -1. Okay, and cotangent, tangent was y over x. So cotangent is x over y, which is 0 over -1. 0 over -1 is 0. And that's all that is. Okay, so you get to practice with those. Okay, now this can be a little bit challenging, but if you followed, what I was doing with these triangles and you remember the definition of this, you won't get it wrong. Okay, and it's really easy with radians. But a reference angle. Reference angles are acute angles made with the x-axis. What's an acute angle? Any angle between 0 and 90 degrees. Okay, but it's an acute angle made with the x-axis. So these problems here, and you actually have to drag a dot around a circle to graph these things. I love it in Delta Math. But anyway, I'll just stop. Sketch each angle, then find its reference angle. So 5 pi over 4. So you look at 5 pi over 4, that's 1 more. The top is 1 more than the bottom. That means it's going to be in the third quadrant. So there's 5 pi over 4 because the 4 is in the middle. Okay, and that tells us from there to there is my 5 pi over 4. The reference angle, okay, is the acute angle made with the x-axis. So that means that's this. So all the time when I was doing that unit circle, when I was building it for you, you need every single time I was doing it, then go away. Every time I was doing that for you, I was pointing at the angle made with the x-axis every single time. Okay, so, but more importantly, the beauty of radians is whatever your denominator is on the unit circle, that's your reference angle. So it's just pi over 4. You don't even have to add or subtract or anything. Okay, -240. Okay, 240 is in the third quadrant, but a negative makes you go in the opposite direction. So when you go in an opposite direction, it just flips it over the x-axis. So -240 is going to be up here in the second quadrant. And when you draw it, you have to make sure. So in Delta Math, if you do this problem, you have to start and you have to go in a clockwise direction when you draw it. That's what makes it -240. This, of course, makes your reference angle. And every time you find a reference angle, y'all, you're either using 180 or 360. So what's the difference between 180 and 240? It's 60 degrees. Do not worry about the negative sign. You're just subtracting the numbers. 240 minus 180 is 60. Okay? Because you're not ever going to have a negative reference angle. It has to be between 0 and 90. Okay? 390. That angle is larger than 360. So if I subtract from 360, I'm left with 30. And a 30-degree angle is like right there. Okay? This is my, that's your, actually, so 390 means I start at the beginning and I go all the way around. That's 390 degrees. But my angle made with the x-axis is that, and that, of course, is 30 degrees because we subtracted from 360. Okay? Now, let's see how they're useful. And one of the reasons for knowing this, y'all, you might use your calculator to find these answers, but you also might get to college and take a class where they won't let you use a calculator to do it. So it will help if you've heard it at least once, even if you don't get it down this time. Okay, these are the steps. You don't have to write down these steps, y'all. I'm just showing you. Basically, when you evaluate these things, you've got an answer. And the important parts of the answer are the value and then knowing what quadrant it's in so that you know whether or not it's plus or minus. Okay, so the steps are, first find the reference angle, then we're going to find the value of the trig function, and then we're going to find what quadrant it's in to determine whether it's positive or negative. So the first one is the tangent of, and y'all, these again are finding the exact values, okay? We're trying to find the tangent of 5 pi over 3. And remember, I told you, a nice thing about pi radians is that the reference angle, if you're on the unit circle, the reference angle is whatever that denominator is. So my reference angle is pi over 3. So then I'm thinking, okay, what's the tangent of pi over 3? And the tangent of pi over 3 is square root of 3. So that's the first part, is knowing the value and knowing that you're in the right family. Now, the next thing you have to do is figure out what quadrant it's in, okay? Where is 5 pi over 3? Well, when you look at this, this is not 1 more or 1 less, okay? And it's not more than 2 pi, so it's in quadrant 4. And in quadrant 4, the signs are positive and then negative. And tangent uses both of these, so if they're different, then my answer is going to be negative. So it's negative square root of 3. Sine of 5 pi over 6. Reference angle, boom, pi over 6. Easy enough. You're looking for the sine of pi over 6. Well, what is the sine of pi over 6? It's 1/2. Okay, what quadrant is that in? 5 pi over 6 is 1 less. 1 less is in quadrant 2. And my signs are negative, positive. And I'm looking for the sine of it. And so the sine of it is just that second quadrant right there. That second coordinate. Okay? All right, last one, secant of negative 135. So when I was building the circle, as I mentioned, anything that ends in a 5 on that unit circle, reference angle is 45 degrees. Okay? Secant is 1 over the cosine. So you're thinking, what's the cosine of 45 degrees? And the cosine of 45 degrees, y'all, is square root of 2 over 2. Okay? But if you flip it, it becomes 2 over the square root of 2. And you rationalize that. It's square root of 2. But y'all, more importantly, you can put this in your calculator just like that. You can put it in class calc. It will simplify it for you. And when you do, you actually get the square root of 2. Okay? Now, what quadrant is it in? Negative 135. Well, positive 135 is in the second quadrant. So I flip it over, and it's going to be in quadrant 3 because you flip it over the x-axis. And quadrant 3, the signs are negative, negative. So that answer is negative. Okay, that's all she wrote. You will have lots of practice, great practice in Delta Math with finding reference angles. But if you have any questions or need any help, please don't hesitate to contact us or come see us. Thank you so much, and you'll have a great day.